Hey guys, welcome back to the channel. I have another interesting video here. This time I'm working still on Chris Wittstock computer. He approved the repair and sent me the parts to be tested. I have, as you can see now, everything computer running. I got the throttle actuator, throttle body, if this will be a vehicle, right, it's like a car, and then the accelerator, and both is called control arm. Again, this is just to show that this is indeed still the same computer. I'm going to take the time and explain a little bit of how this whole system works. I even have an amp clamp connected here, well, the meter, connected to read the amperage on the motor. And I want to show you that if I move here, the motor moves freely, full to open, and we can see the amount of amperage is drawing when it's completely fully open. We can see that the motor, if I hold it open, is drawing a little over 4 amps, and that is completely normal, and it goes to idle. So let me just bring the screen recording so we can all see this. All right, guys, I have the screen recording going. We have the values. This is DIACOM, and we can see that we have everything connected, and I can read RPMs as usual. I can, select and see those in here, but for the test that I want to do also, maybe it's not the best, but well, for now, let me just put it so we can see that we got RPM, and I can increase the RPM just changing this knob in here, and you will see that changing. As I change, that will also try to move the throttle a little bit because it's expecting higher RPMs for the throttle to be moved, and we can see that the throttle is moving, and this is moving pretty good. The other thing that I have also in here is the oscilloscope connected. Let me move this here, and then when I open the oscilloscope, that will stay there. So as you will see on the bottom here, I got the notes, and it says which each channel is. So TCP will be the signals in here. So we got TCP 1 and 2, and then in the throttle body we will have TPS 1 and 2. All right, so again, you have the channel colors and everything. I just got rulers on these two channels because realistically what I wanted to see was the minimum on those two channels, and I will explain that also as we go in the video. Connection wise, I have also that here. Let me actually bring DIACOM down and this one down for a second, so you will be able to see what I have here. So these are the connections for the throttle control position arm, and then for the throttle body. We have, let me close this one for a second. On here, it tells me that the again, throttle control arm or throttle control position, that's what a TCP means, right? The control arm signals as we see. So this is the connector that I have in the control arm. So again, the pinouts will be facing the connector in the front. It's pretty good. The actual diagram is pretty correct. I'm sorry. Um, the computer will send 5 volts onto this pin on pin 8 for the IBS sensor, and the IBS will report if it's an idle or not. So we have all those signals in there. The TCP control arm has 2 signals, again, TCP 1 and 2. It has 2 voltage reference, very important. It has to be checked that the volts, 4 or 5 volts, because are completely separate fiber reference, they're not shared, and they're very specific position-wise. So we want to make sure if you're doing the test on the boat that you're checking voltage reference on pin number 4 and voltage reference 1 on pin number 6. And then the IBS ground is also very important. That's chassis ground or battery ground. It's not a sensor ground, it's a separate ground. All right, so these are the same connectors that you can see in here. And this is the actual pinout, right? So I compare, everything is perfectly. These colors matches exactly the back of that connector. So everything is 100%. As far as the throttle body, we have the same thing in here. I am able to have the throttle body, and this is the pinout as the arrow shows from the actual throttle body right here, right? So we got A, motor positive, B, fiber reference 1. In the throttle body, it uses only fiber reference 1, and that is also very important. If these wires are messed up for any reason, this will not work properly, and then that will be a problem. But yeah, so we got C as a motor negative, then D as TPS1, E TPS2 ground, and then F TPS2 signal, and then G TPS signal 1, H fallable reference for TPS1. And we can see that here on the diagram. Again, this is for these motors, and then for these motors it's the same. And it's the same thing that we discussed before, right? So same pinout, same connectors. This will be the connector on the boat, as you can see, because if we see right here, we got 8 on the left, and we have see here 8 on the right. So that's why it's sometimes you have to be careful, especially like in my case, because I don't have the boat in here. So I have to really kind of like think about and make sure the connections are correct. That's why following uh, color wiring is easy. On here, it's impossible because no wires, right? That's just a connector. So, but a good way to find out which one is the correct wires, uh, we got motor positive and motor negative. That should give me um, some sort of a ground, right? Because it's a motor winding. I mean, not ground resistance. So that's also good. And that's how I check it because the sensor grounds in here, TPS1 and are not shared internally. Did I check that one in here? Let me take that one back because I don't remember if I checked that. But yeah, so these are the connections. So this is exactly how I found, and this is all DIACOM information. If you need to find that, you can go back to DIACOM. Again, DIACOM is the diagnostic software that I'm using for here. And you can just go into manuals. You can go, well, I forgot that we're seeing here. Volvo Penta, you double click in there, and then you are in 4G. Let me just make sure, yeah, 4G, and you can go into either of these ones will work, but I think this is a GXI, so you just click, and this is the workshop manual, and then just find again all the diagrams. I mean, I can give you the pages, but yeah, you can see the manuals are here. All right, guys, so okay. That will be, I don't want to take too much time just to explain, but I show you where they are. So to connect to the computer, I just go here, select Volvo Penta EGC. This is a serial connector, not a CAN. This is a 2005, 2006. So let me just actually take a look, and I go into engine data, connect to the computer, and then we can go into system info, and that will tell me what year is this. So this is actually 2006. So that computer is from 114 2006. That is the serial of the boat right here. 412 for the computer, 412 18 46 77. So, and this is, as you can see, an 8.1. All right, so everything is now working good. I don't have any drops, any cuts. So let me get Diacom in the front small so we can all see here. Retrieve inactive codes. I don't want to get codes. So we are connected. Well, yes, since we are there, let me just get to code. So I did erase because he has TPS1 or TCP2 faults. These aren't the only faults that are here. I want to lower the RPMs because right now I'm in 1338. So let me bring the RPM down to the side idle, and we can see the throttle body trying to move. You see that? Because I'm raising the idle. So this is also, when you have a throttle body, you will have no IX valve because this acts as the same. So this is what we're seeing right there. When I come from idle to a higher RPM, this will act to open and close. So it will let air come in to adjust the idle, like the same way the IX will do, right? All right, so let me bring it down to 650. Around there. So, yep, around there. So we are perfectly, and you can see that when I'm in there, everything is normal. I can move throttle body, and you will, guys, don't hear that. But when I do this, since I am in idle, the throttle body should not be moving this. Of course, I'm doing things the computer is not happy, and I can hear trying to put the boat into leave mode because if something is not right. The throttle is opening when it's not supposed to. But so the computer logic is perfect. I don't see any issues. So the other thing we can do, and I showed this before, is you can go over to test, and then this will stop the communication, do the drive-by-wire test. Make sure that you perform this key on, engine off. So for this, I'm going to turn the computer off. No more injection. Everything is in zero. And then we can now do the test. We can start the test right here. This will move the throttle body now to the zero position. As you can see in the screen, we are now in zero because it's doing the test. So it wants to see the zero perfect position of the throttle body, which the computer is in 100% control of it. And we can see that it's doing at minus 3 amps to keep that valve shut. Why? Because again, this is an IAC in a throttle body, right? So when this is in normal operating, it's going to be around 13% or so. Why? Because it's letting some air go through to keep the idle of an engine, of a normal engine running, right? Because if we have the throttle body completely shut and we don't have an IAC valve, well, this will stall the engine. Even though we have this other hole in here, is for something else. So again, this is, like I said, why is that? But yeah, so with this test, what I'm doing and what I want to do, and this is what you can also do in the boat, you will need an oscilloscope, obviously. Let me get out of the test 1 second to make this even a smaller. I can do DIACOM small only when I am in here, and I can probably try to see. Yep, that's the test. Perfect. Now we can start that. We saw that again, moving the throttle body, and everything is in zero. So perfect, right? So that's what we are looking for. I can move these two channels a little low so we can see them. I move the cursor and now the channel. Try to keep the cursors in there. All right, so we are all agreeing in zero, as you will see on the screen. So I'm going to move this, and as we move this, you will be able to see the results up the top, right? So we're looking for glitches, looking for to make sure that throttle and TPS and TCP are all going the same way, right? So we're going to zero. They all should read zero when they're in minimum, 1%, 2, and that is a little bit of a lazy switch in there because it should go back to zero. And maybe if I click it, it probably will. Well, one is not, it's not bad. It's not going to set up a fault. But we can see how the TPS are going, and now the TCP is to 100%. We go back to zero, and you see now it went to zero. So definitely we have a little bit of a lazy switch in here, but nothing that will set up a fault, at least not yet. And this is what I want to do. So I want to stress these with the throttle position, I mean with the throttle body and everything. You want to go slow from minimum to maximum, and what we're looking for, I'm going to stop doing this just in a second, but you can see how they're going up and down and up and down, and our recording is in there, right? So and everything is looking good as far as numbers on the DIACOM values. I don't see nothing that it will trigger a fault, so we can stop now this capture, and then we can now go and try to analyze this data. So what are we looking for? Let me remove these rulers, we don't need it in here. It's kind of like these glitches we see here. So, but again, remember, it has to be a very big glitch, so we can definitely analyze a little bit in here. You see, because as I am going up, we can see when the throttle command is changing, because that accelerator, let's call that accelerator because that's what it is, right? When you accelerate in the engine, if the accelerator pedal, or in this case throttle command, have a glitch, it will make the throttle body react to it instantly. And we can see that because remember, this is an input and this is an output. The throttle positions indeed are also inputs to the computer to make sure that what this is commanding is happening in here. Because this will move the motor. The motor is being moved by this command, and then the computer will read the TPS1 and TPS2 to make sure that everything is as close as possible. And we can see that happening in here. As I was accelerating, we had this little glitch, and that could be my hand because again, I'm just doing it when there. So maybe as I grab it, because usually when you have a drop on a signal. It's not like that. It's usually a drop or a high spike, nothing like that. So this I would not consider a problem. So this is not what I'm looking for. A little bit in here, yes. Let's take a look in here and see how that looks. Again, let me see the actual filter because I did put filters in here. No, it's not the filter because just the way the channels on these oscilloscopes are. But no, because I removed the filter completely. Make sure that you, if you're using an oscilloscope, make sure that you take filters off and filter back on to make sure it's not a huge spike that you remove by applying a filter, right? And that's not the case here. So let's go back a little bit. I don't like that little bit of a noise across the signal in here, but again, I don't see a drop. And remember, I'm going very slow. You're never going to do that in a boat. But yes, this is what you want to do as a test. Everything looks good. I don't see glitches in here. This is just small bumps that I did. And we can keep doing this test. So let's keep doing it again. All right. So that's what we're here for, right? So we're going to, because you see, I'm going very slow. If I go fast, let's do this fast. Let's see how that will look, right? All right. So let's just stop the capture. Values in DIACOM. You see, this is a little bit of a difference, but 1%, 2%. Again, that's in the TCP. We can see that here. I know that you guys are going to look at this, but I always try to point so you can see my hand. So we can see 1 and 1. So TCP actual is 1, TCP2 is 2.7. So it has like a 1 degree. Uh, we're looking for like a little higher than that. It's a 10%. Remember, there's only 1% difference, so that will not set off a fault. And this is here. Disregard that changes and when I am accelerated because the refresh rate is what you're seeing in there. Wait for that to stop and then read it. See right now, and there we got like a 1.6%. And this is what you want to do. You want to leave it because as voltage goes through, things start to get a little warm. Not too much because obviously this is a control environment. I don't see still nothing that really will give me anything to consider wrong. I mean, this is 1.2 difference, so nothing that I see that can create an issue. So let's analyze this second movement, and you can see there is following really, really good. We can move the channels. Oh, what happened here? Glitch on my scope. That was weird. Yeah, I went with this one up and I lost the entire all the readings. But yeah, like I said, this is nothing that I can see that is a glitch. These are just perfect mirror. I don't see nothing really catching my attention. And this I was moving very quick. And this is what really you need to do if you are in the boat and you want to do this. You got an oscilloscope and you want to get this done. You can do it. Definitely. I'm going to make this smaller so we can see the signals a little more. And I'm going to do it again. All right, so that's what we're here for. Trying to get that to stay in 20% because if we got, one in 0 and another one in 20%, that's it. See, and this is, I don't know if you saw right there, I went 0.2 and 0.7. So definitely the TCPs 1 and 2. This is a little glitchy, not too much. See right there is 1.5 and 1.5. I mean 1%. Let's go to maximum and maximum, and there we have like a 2.5%. TPS 1 and 2 are perfectly matched. See right there. I mean, Chris, looking at what I see here, I will definitely recommend to replace the control arm. This is a little glitchy. The throttle body is right in the money, moving exactly as commanded. I don't see anything that really, shows up from the rest. I don't see glitches, which is exactly what I was trying to look for. See right there is very, very close. But I can definitely see a small difference. You see right there, right there is like zero point 0.3, 0 0.1. That's what we're looking for. That a 1.5, I don't like this. And that is definitely in there. Still, for my experience, I don't see really this as the culprit of, sorry, of what you got in the boat. But definitely one thing that I cannot reproduce 100% is vibration and heat. So when you start in the boat and everything is, heat up and harnesses start to get really hot because, all this transfers heat. This might be, creeping out more. But I definitely don't see any issues on the throttle body and definitely nothing on the computer. The computer is working 100% and we can, start it. We're running. Yeah. And I come here. Oh, yeah. Let me exit this. Should have exit this first. And we can read the codes. And we have no codes as far as TCP 1 or 2. I can definitely hear when I reset the folds, the throttle body tries to adjust again for the IAC position, idle position, right? But yeah, as you can see, there is no faults related to TCP1 or TCP2 here. I'm gonna just let the computer run in here for a while just to see if anything changes just by running an idle. Then I'm gonna move it in probably into like I don't know, maybe 2000 RPMs, hold something on the control arm and see if it's any changes. But yeah, Chris, I don't see anything here. The only one that I would recommend to replace will be that TCP. And yeah, it's probably your best call to do. The throttle body is in perfect shape. All right, guys, already 22 minutes. I hope that you guys like the content. And yes, you can do this. It's a lot of time consuming to recreate all these signals. Sometimes people don't understand how intricate it is to test something like this. It's taking time to run those extra wires. Even if you have the entire harness from the boat, it's not the same. You don't need all that in here. You will have all those connected to the simulator, yes, to reproduce temperature, map sensor, and etc. But then you have to get the signals for that motor actuator, TPS 1 and 2, 5.0 reference, sensor ground, and then do everything for that order switch in there. So it is time consuming, but definitely if you have a problem and you need to test all this, yes, I can do it. It's not a problem, and I can give you with accuracy what the problem on the components or in the computer, or if it's not in either of these components, and then it's a harness, right? Because that I cannot test, I don't have it here. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.